Charlie Faulkner, welcome to the Pacey Performance Podcast. It's a pleasure to have you.
Cheers, Rob. No, I really appreciate the invite.
My pleasure. Thank you for coming on. I know it's taken us a little bit of time to line up, but all good. It's a pleasure to have you and speak to you this evening. If anyone doesn't know who you are, Charlie, would you mind just giving us a bit of a? I'm going to give you 2 minutes, a 2 minute bio, and then we'll dive into what we're going to chat about today.
I'm Cap. I'm used to these. So my name's Charlie. I currently work at Manchester City Women as a first team physical performance coach. I started my career just over 10 years ago now. So I came out of school, took 2 years out of school because I didn't know what I wanted to do. I went to the UKSCA, one of the foundation courses with my cousin. Thought, okay, I want to work with athletes. So did my BSc at St Mary's in S&C, and alongside that I worked at S&C facility in Weybridge called Locker 27, and then I also balanced that with began working at Wasps Academy rugby in my second year, and did that for 3 years. I worked with water polo for a year within that time frame as well, and then I want to say 2019 I finished at Wasps, and obviously I'd done my undergrad, started an MSc,
At St Mary's
which
as well.
at St Mary's as
Yeah.
well, which I finished, but I didn't get my MSc. I got a postgrad diploma because I didn't finish my dissertation. And then through that period of time, I wanted to go back and work in professional sport. So I applied for a job at the Lawn Tennis Association, and I spent 3.5, 4 years working there, with British athletes, both female, male, all the way through the development path to the elite athletes down to the younger athletes, and I decided I wanted to change, go back into team sports. So last year moved up to Manchester, and about to go into my second season, or in halfway through the second season in the WSL.
Interesting. I did exactly the same on the masters, by the way. Got the dissertation and thought, I don't know if you were the same, but I've kind of learned a lot here. I'm not, for the time commitment a dissertation's gonna take. I'm probably enough there. I've learned what I need to learn. Do you feel like that's held you back, that you haven't got the MSc and you've just got the postgrad diploma on your CV?
No, I don't. I think like it was a similar reason, like the timing of it, where I'd started my MSc maybe a year and a half, 2 years before I got my role at the LTA, which was my first full-time role in professional sport. Um, and it coincided with COVID, like really closely to COVID. So that kind of threw a load of spanner in the works. And then because of my schedule in tennis was like up in the air all the time, I didn't know where I was going, when I was going, who I was going with. It made it really difficult to commit to writing a project and doing a dissertation. So, like, both for my own sanity and for my job and like the athletes I was working with, I thought it was the right decision to kind of put that on hold, and I decided to, like, I'm happy with the postgrad diploma. But no, I don't think it held me back in terms of where I'm now moving forward.
You stuck to your 2 minutes, I think, so we're all good. I'm happy there.
Nice.
So we're going to dive into deceleration and change direction, which, you and I talked about before, they come together as a pair. This isn't on the list, but I'd love to be able to get your kind of overall philosophy on this kind of area, and then we can dive into the tennis side and then how that's converted to the football side.
Yeah, cool. That's a massive question, but it's something I've probably spent over the last 2, 3, maybe 4 years, like really thinking deeply about. So I have some opinions that for me are coherent and aligned to some of my beliefs and my personal philosophy around training. So yeah, I'll try and summarize it as best I can. But um, I think how I look at the world now is very much from like an N equals one, like performance backwards approach. And a lot of people in sport now talk about performance backwards, reverse engineering the sport, and understanding the critical determinants of the sport. And I think that's just done now in sport throughout, regardless of what sport people are in. So for me, I view this like top level of like performance as like having a real clear understanding of what the demands of the game are. And that's typically will be different, obviously, between tennis, between football, between rugby, but that then allows me to understand the demands of the game. And then what links in really nicely with that is understanding what it takes to win. And that's probably a phrase that's been thrown around or come out of evolved from the English Institute of Sport back in the day, but it's, to me, what that means is it's understanding, or having a really clear understanding of what are the critical determinants of winning. And that is probably within football, that's at a really high level. And then that can also be honed in on individual as well, and understanding what the specific demands or specific parameters of what it takes to win mean for that player. What fits under that for me, so the level below that, is an athlete's, or the athlete's ability or their capabilities around movement and their movement preferences. So that fits really nicely with how we kind of call it in football, or we phrase it in football, and how we phrase it in tennis is like high intensity actions. And I'll answer the question that you said we were going to move on to now around football and tennis. So in tennis, we would define the high intensity actions as your first serve and ball free. So make your first serve, recover behind the baseline, hit your ball free. If you get forced out wide to play a shot outside the dimensions of the court, so if you start in the middle of the court and you have to move outside of the tram lines to play a shot, that would be another high intensity action. And then the final one, which is probably the most obvious, is the drop shot. If you're behind the baseline and someone drop shots you, you've got to accelerate really hard, decelerate, play the shot, and then get back into a position to play another shot potentially. In football, it's a little bit different. So you have your you have your in and out possession transitions. So if you're attacking in the final third and the ball gets turned over and it's a quick break or a counter attack from the opposition, the transition is being able to run, get back into a defensive pattern and defensive shape, and then pressing, counter pressing, and probably also would put in there, the coaches would probably not like if I didn't put this in there as well, but 1v1 defending, which is obviously really, really important as well. And then within that, you have these high intensity scenarios which encompass a multitude of different high intensity actions. So when you've got the high intensity actions, underneath that would fit the movement aspect. And for me, regardless of the sport, I think you break them into acceleration, change of direction and deceleration, and max velocity sprinting. And then that will then formulate how I would then profile like all of them differently, and we can touch on that later for sure. But for like deceleration, change of direction, like I said before, I couple them together, and for me they sit hand in hand, and I appreciate they're both very different biomotor qualities, and they require different like physiological stimuluses, let's say. But I think if you're looking at a change of direction and you're looking at a high intensity change of direction and not a cut, there has to be a level of deceleration within that. And if we define deceleration as a reduction in momentum or a change in velocity as per se, and then the change of direction is then having to re-accelerate yourself in a different direction, I think, again, like the reason I couple them together is because how I profile them, and how I profiled them both in tennis and in football, allows you to get both from the profiling and from the test. I think when you look at deceleration as an aspect of a change of direction, it's defined by a reduction in momentum, so that's a change in velocity, and the athlete's force capability. And ultimately, both of them come down to are determined by the entry speed and then the re-acceleration speed or re-acceleration position. So if you run faster and want to brake quicker, you have to produce more force into the ground, because we know that higher speeds result in higher ground reaction forces. And if you want to brake them really quickly, you've got to produce higher amounts of negative work or higher amounts of vertical ground reaction force into the ground to slow yourself down, which then fits really nicely with that idea around the force capability or potential of the athlete. And then in terms of if you were to break then down deceleration within a change of direction, and the key positions that are commonly reported within the literature, you have your penultimate step, your final foot contact, and I saw more recently actually people looking at the anti-penultimate step as well. And I think when you look at the penultimate step, that's clearly defined as your big braking step. So the step before the change of direction step, that's defined by having contact in front of your centre of mass, this contralateral upper body rotation towards a stance leg, and an active foot placement, which means that when the knee travels over the ankle joint, the foot's flat on the ground. And you typically see greater ranges of motion in that position, because that allows for an increased amount of braking force to be applied into the ground. And then your final foot contact is defined as your cutting or your change of direction step, which is that last step. And if it's done efficiently, so you're able to load that penultimate step really well, your final foot step should make the most out of what the ankle's designed to do, and that's spend as little time on the ground and be really reactive off the ground. And there's a load of body of research now suggesting that elasticity around the foot and ankles are highly correlates with quick change of direction times.
So I feel like we've got a bunch of discussion points, but we're going to go off piste here because there's so much to go. I mean, we'll follow it roughly, but there's so much to go out there. So in terms of training deceleration, do you in your mind, are you separating the two when actually training, or does one do they come as a pair in that essence as well, not only philosophically but actually training wise?
Yeah, I think so. Yeah. I think it depends how you look at it. So the reason when we profile, and I have profile before change of direction, is typically, it's an out of context change of direction, which means you know what you're doing. It's pre-planned, and without jumping ahead, we'll do a modified 180.
Let's go into it now. Do you want to do the profiling in tennis?
Yeah, I mean, it's very similar to
okay, perfect. Let's do it.
Let's do it. So in terms of how we profile, or first and foremost, it's coming up with a question that you want to answer. So the question that we want to answer is, are our players, and this fits within both tennis and football, and I would probably apply this to rugby as well if I was profiling back in rugby, but can athletes brake really hard and deal with high amounts of ground reaction force? So to do that, you have to have the athlete running in really quickly. So that was a prerequisite on the test that we chose, because I think there's some really good research out there, and there's a lot of protocols that just use the 505, but one of the limitations with using a 505 is 5 meters in and then 5 meters back probably isn't representative of the higher speeds and the higher forces that athletes are going to have to deal with within their context, in most cases, in most sports. So what we do is we'll use modify 505, which is in essence a 10-meter run in and then your 505, and we'll set timing gates at the start and then at the 10-meter point, which is also 5 meters away from the touch line or the cut line. And what we do is we get them to run 10 meters as quickly as they can, and we get the 10-meter time. And then we basically say to the athlete, whatever side you change direction on, you have to run in to your change of direction within 90% of your initial 10-meter acceleration, which then standardizes and we can then be confident that the intent is to run in really hard and fast. Because what you can get is, if you don't monitor for that, people will start braking really early, and therefore they could get a really quick change of direction time because they don't have to brake quickly. They can just reaccelerate and then change of direction. So we use timing gates there. We also, in tennis, we used the opto jump. So we had 9 meters of opto jump. So we were able to get step frequency, step distance, step velocity. In football, we're using the sprint 1080. Which doesn't necessarily give us all of that, but it gives us some potential. It gives us similar metrics that we will then utilize to understand someone's deceleration as well as their change of direction capabilities. And then also we use the cutting movement assessment score from Dos Santos. So we'll film in the sagittal and the coronal plane, and then in pre-season for me, it was basically spent all my time watching people move, cutting loads of pictures and creating this movement profile. And it looks really fancy when the players walk out onto the pitch and you've got all this kit set up and you've got about 3 or 4 members of staff holding cameras with the laptop out. But we think it's really important and it's really useful. It gives us some insight around how people are choosing to move, which for me is really key in my own personal philosophy, which is evolved and developed especially since I've started working in football. And then gives a real good understanding of the movements that are really important on pitch, how well are our athletes able to do them. And just quickly jumping back, obviously the change of direction is out of context, but what it allows us to do is, if a coach comes to any one of us as a physical performance team and says, player X, for example, is they look really sluggish and slow in their change of direction, we can then come to the data, look at the test, look at how they're moving, and potentially we could go, actually their change of direction time is really, really good, they brake really well, it all looks really good. Actually, what might be the limiting factor is their agility, which we know is defined as, or the difference between that and change of direction is a change of direction or a change in movement, or distance or whatever we want to say in response to this external stimulus or the sport specific information. So that then allows us to have a conversation with the coach around, okay, can you show me the situation where you think the player's sluggish, they're slow, or they're not able to change direction? We can get a little bit more information around, okay, well actually that direction training, instead of just doing a load of change of direction stuff, doing more agility based training, and how can we design more drills or incorporate stuff within actual football where players are having to make decisions and react to what's going on in front of them. Jumping back to the profiling bit, so obviously got all the 1080, the timing gates, the video analysis. What we'll get is we'll get the 10 meter time, we'll get the 5:05 time as their like performance time, we'll get their max velocity in from the 1080, and wherever that max velocity is, we're then able to work out the distance from their max velocity to zero velocity, which is the change of direction, and that gives us our braking distance. And then in the 5 meters out, we're able to get their top speed in the 5 meters out. So we're able to work out how quickly, what speed do they get to on the way in, how far out from the line is that, which gives an indication of how well they can brake, and then how quickly can they re-accelerate out. And then we can use that in conjunction, which I think is really important, both working up the framework and looking at, right, what's important on pitch and how does that look on pitch, and then working down the framework towards our like more like static physical profiling markers. So a single leg iso squat, your counter movement jump, your RSI, and like how do we pull it all together and understand, using our physical profiling and using those like isometric based testing, let's say, to understand how someone's choosing to change direction. And I think it within my philosophy, it's really like this idea which I've transferred over from tennis, working with individuals, of this n=1 approach. Like every athlete is different and every athlete will move the same and have different anatomy, even though that they're required to play the same sport and do the same sort of movements. They'll all do them in very different ways, and that's where for me the physical testing allows us to gain an insight in, okay, why is the athlete braking really early? Is it because they struggle to load their right leg on a left-sided change of direction, so their right penultimate leg, that they're not able to produce the high enough amount of force? It then just gives you a little bit of context around why they're choosing to move, and then understanding, is that a limitation? Is that something we then want to go and work on?
Just out of interest, if you hadn't have had the opto jump in the tennis and the 1080 at the club, would you do anything different if you just had timing gates?
I think with the timing gates, what's really useful is, because you get that 10 meter time, you almost get an idea of their break. Like if you don't, well, even if you do tell them they have to get within 90%, some of them just won't for whatever reason. So that will tell you something there and then. What I probably would do is I would stand further back and film, instead of filming like the last bit of the change of direction, so we get the penultimate step and the final foot contact. I'd probably have someone standing a bit further back so they capsulate it all, because what you could then work out is, and then there's a load of AI stuff out there at the moment, which you could utilize. But you could also, just from visually looking, as soon as that first step is in front of their center of mass, you could then work out their step frequency. And it might not tell you like what it will tell you is, it'll tell you their strategy for change of direction. Whether that's a good thing or a bad thing, it'll just tell you how they're choosing to decelerate and how they're choosing to cut. And again, one of the other things why we use if deceleration is defined as reducing your velocity to zero, you get that within your change of direction. But what you also get is you get a left and right score, so you can start to look at their change of direction when they have to cut off their left leg and when you cut off the right leg, and then that allows you to pull in all the other testing data that we spoke about to make some. One of my old line managers used to say, pulling golden threads between the data to make sense of the world and how the athletes are choosing to move, which I think is really neat.
So when you look at potential injuries, it's the CMAS that you're using within this protocol that you've just highlighted there on that injury reduction, injury prevention area.
Yeah, definitely. I think like.
Sorry, Charlie. So for anyone that doesn't know the CMAS from Tom DeSantos, just explain it for us.
Yeah, cool. So it's a scoring system where you can video someone's change of direction. Specifically, you video that penultimate step and the final foot contact, and then I mean, you have to screenshot them or watch it in very slow motion to get the positions right. And then he has a scoring system, we use it for the a 180 change of direction, but it was originally put in the literature around a cut. But I think the principles stand the same of that penultimate step, final step, and they still want to see similar positions regardless of the cut, etc. And it basically allows you to score off different positions within both the penultimate step and the final foot step. And basically, a higher score indicates a higher risk of, I don't want to say ACL, that's not right, but like putting the knee in, like basically around knee abduction moments and the position the knee is in when you're changing direction, because that's a common position and a common mechanism for knee-based injuries. So yeah, it's really neat. I like, when I first got introduced to it, I didn't really understand, but the more I've watched people move, the more I've used it. I wouldn't say I'm an expert by any stretch, but I feel pretty confident that I'm seeing, I know what I'm looking at, and I've honed it down to being quite glued on with my coaching eye. And it's been really like the practice or the task over the pre-season of doing that of the whole squad. It was so long. It took me so long, but it was so useful in one. Like, even now I can probably talk through most of the players and how they're choosing to move and like the differences between left and right, because I spent so much time you pulling the data out and going through each one of their like CMAS.
I know you mentioned about pulling the golden threads between all the different pieces of the data, and that's quite a nice way to look at it. If you identify that someone's breaking early,
Yeah.
what is your first port of call? What bit of data or what comes into your head instantly, like, we need to check that? That's the first thing we do.
Yeah, I mean, first and foremost is, are they breaking early because they've either had an injury or have got a current injury that's potentially limiting them in doing that and wanting to offload that area or joint, let's say, or tissue. Then my next point of call would be going straight to like our force-based data. And again, it's pulling it back to my philosophy, well, I say philosophy, the understanding of like, when you're running fast and you're braking hard, like you're having to deal with very high amounts of force. So you have to have the force capabilities within the lower limb to support that. So I would look at like any of the force-based data that we have, and we collect single leg ISO, single leg ISO squat, single leg ISO calf. So I would look at that. If we have anything on the Kangatech, which is a fixed dynamometer, either around the hip or the knee, I would look at that as well, and that'd be my first point of call. And then what I'd want to do is I'd want to try and make a hypothesis around why they're breaking early. And in most, and look, again, I'm probably, if I haven't got anything from the force data, like the isometric force data or anything around the Kangatech, then I'm probably going to look at their their RFD, whether that's on a single leg jump or a single leg RSI, and I'll probably then make an assumption or make an educated hypothesis around that.
I'm going to keep going down this track, so I'm just going to ask you hypothetical things. So that you understand, you've looked into the data, and
Yeah.
the force is down. Where then?
This is probably tying into, I guess, getting into my overall philosophy around
I
training.
won't keep going, Charlie. I won't just go, what
No,
if,
it's
what
fine.
if.
It's
But
fine.
I think this could be a nice one.
It starts like I'll dive into it, but just for context, like my training philosophy, I think is simple. Maybe it's not. Maybe people challenge me on it, but ultimately, it's in my job. It's trying to create a physical change that perfects performance. So that means if I'm doing an activity in the gym, on the pitch, if I'm giving an exercise to someone, it should be used to make a physical change, and that physical change should be related to performance. Hence, why I've said about this movement, like capability and preferences, understanding someone's movement, understanding the cost of that movement on their body. That's based on whether they have the underpinning physical qualities to support that. I'll then use a framework that has been presented to me a number of times. It's a conceptual framework that was designed by Alex Wolff and Chris McLeod, and it basically stipulates, and I hope they correct me if I'm wrong with my interpretation of this, but creating change, you either create structural change to the tissue. So that might be like changing pronation angle, physiological cross-sectional area, muscle fiber length, sarcomeres and series, etc. Or you're creating a neurological change to the tissue or the joint or the whole system. And that will be either local, at local level, so like a muscle tendon unit level, or a global level. So that allows me to then be really clear on my exercises, like where am I targeting my exercises, to affect the movement that I want to change, if that makes sense. And then that's based around. Sorry, go on.
No, go on. I was just going to say, can you give an example of that?
Yeah, like I could probably link it back into that change of direction piece. So like, if someone was braking early on one side, and I went through the force data and I found that, okay, like, so if we're cutting on the left side, I'd want to look at their right force capabilities, because that would give potential indication of their penultimate step and their capability to offload that final foot contact. So I would look at their right side if it's a left change of direction. If I saw that that was down, we know that from all the from the literature around the penultimate step, like, you're loading the knee and the ankle predominantly. Tying that into like all the architecture research, the muscle architecture research from Sam Ward, Richard Lieber in the early 2000s around understanding how a muscle is built will define its function. So we know that vastus lateralis, soleus, glute max, adductor magnus are like your massive force producers within the lower limb. So I'd know that, and then the literature supports that with change of direction and deceleration, that your calf, soleus, vastus lateralis, and your quadricep group are like really key. So I would then want to maybe look at something specific around the calf and the knee. So from a structural perspective, I'd want to change the physiological cross-sectional area of either the vastus lateralis and the soleus. So that might be doing high force or strength-based training around seated calf and around the quadriceps. And within that principle of like anatomy based on movement, like, I would remove the constraints to the exercise. So if I want to train the soleus, I'm not putting myself into a lunge position and doing like a single leg heel raise, because there's too many other things that are coming into play. So I'll put, like, we're lucky that we've got a seated calf raise machine, so I'll put you on that and I'll get the load through there. If I want to load the knee extensors, this is really controversial, but I wouldn't go back wouldn't go back squat, because I think the limiting factor in a back squat is your lumbar spine. So my view is, if I want to overload the joint and I want to overload the tissue above its habitual capability, then I'm going to remove the constraints around the exercise. So I'll probably put the athlete on a leg press and put the position in a low foot position, which increases the dorsiflexion and the load at the knee, or I'll put them on a leg extension, or I'll use a combination, and I'll use that. If I'm going after a local coordinative change, then what I'm probably going to do, and there's a really nice paper, I don't want to guess the year, but it's from Zebis. I want to say it's 2008, so I've just guessed the paper, but basically shows that doing a kettlebell swing has very similar electrical coordinative activity of the medial hamstrings compared to a cutting task or a change of direction. So it's very possible that you can actually train coordinatively the muscle tendon unit of the medial hamstrings in a similar way that you're gonna cut in a change of direction based task. So that would be my local bit. There'd probably be a bit around hops and change of direction as well, and hops and doing like different hopping tasks, whether that's a drop jump or single leg drop jump. But the principle around that would be making sure that the rate, magnitude, and timing of muscle contraction is as close to the change of direction as possible. And I did a really cool bit of work actually over the off season with an athlete who's come back from an injury, where I took a load of different activities and I had some normative data around peak forces and contact times of the penultimate step and the final foot contact of change of direction. And what I did is I did a load of different activities with this athlete, getting them to drop off a box of different heights onto these force decks and then back up, because what I wanted to do is I wanted to try and create the conditions that were as close to, at a local level, at the foot and ankle, and potentially you could argue the knee as well, of what they would experience in a change of direction. And we got to this drill which the athlete would start on a box, and they just say they would jump with their left leg would land, the right leg would get over the left leg, so they'd be facing one direction, and then they'd have to jump back onto a box just below. So if you can picture that, if not, I don't know if I have a video or anything, but basically I did that, but on a force deck, onto a force plate or two force plates. So you get the penultimate step when they jump off that initial step, and then they get the final foot contact before they then have to jump back on the box. And the bit that's really key is that putting the box in the position that I put it in to jump back onto gave the intent of getting onto the floor and then getting back out as well. So I got the I got contact times that were under change of direction contact times for the penultimate step and the final foot contact, and I got peak forces that were above as well. So then I started to use that from a local coordination based approach with that person in terms of looking at their braking strategy, like a real life example, returning from injury. And then the global bit is more, and again, I don't want to cop out here, but it's more like what they're doing in training. So if you want to overload a change of direction in training, there's a load of different ways to do it. Like again, you could use a change of use the 1080 and use assisted, so it's pulling you in, so you overload the obviously the braking element coming into the change of direction. But in tennis, I used to do a cool little drill. It might not be cool, but I did a drill in tennis where, and again, it was playing around, where the athlete would start on the baseline, on the service box, middle of the service box. I'm forgetting my tennis terminology. Start in the middle of the service box, and they would have to, I'd throw a ball up, or a tennis ball into the air, and they'd have to run to the outside tram line and back and catch the ball before the second bounce. And it took a lot of playing around, because I had to play around with how high I throw the ball, so I didn't make it too hard, but I also made it impossible. And it got to a point where I was then thinking, okay, where's the intention within the drill? Again, one of the principles of the global coordination-based training is around making it look and feel as close to what they're going to have to experience in a match. And there's probably an element of, actually, because they don't have a tennis racket and it's not anchored to a movement, it might not fit within that, and it might be more towards the local element, or the local coordination changes. But what I tried to do then is I got the athlete accelerating towards me, and then I threw the ball. So they're running fast, and as soon as the ball gets thrown above their head behind them, they have to slam on the brakes, get themselves into a good position, and then re-accelerate to catch the ball. And I found that actually, just visually, and again, what I could have done is I could have used the opto jump, and I could have used that to kind of give me an indication of like braking distances and step frequency, etc., to kind of validate what I was doing. But because the intention was run really fast and then I throw the ball, the intention was to brake really quickly. So that's how I would then pull it full circle. And then I'd probably be really curious within that, and I spoke about this when I wrote the article, of being really reflective on, these are the things that I think are going to happen, and I'm using these different methods of training, but I really want to know whether they've had an effect. And it is sometimes difficult, so you always go back to that. Well, I'm going to change. I'm going to retest them on the change of direction, and if they brake quicker. But I'd also then take that step further and go, okay, well, within, when I'm programming for my seated calf raises, or I'm programming for my knee extensions, I want to know what the athlete currently can do, because I think that's the whole point of creating adaptation and following an adaptation-led approach, is overloading what they currently have. So I want to know what they can currently do, and that might just be a rep max test. I might just put a random weight on and go, how many reps can you do, and use an online calculator to work out a 1RM, and then I'll be really clear on what I want the athlete to get to. So with my soleus raises, for example, I'm really clear that I want the athlete to be able to get to 4 sets of 20 reps at 2 times the body weight. And I know a lot of the research stipulates that from an isometric perspective, the soleus should be able to just produce 2 times body weight, or that's probably gold standard. But when you combine that with the architecture stuff I spoke about before, and actually the soleus is really high force tissue, but it also has a really high metabolic capability as well, which is why I used to get a load of tennis players getting to 160 kilos for 4 sets of 20 seated calf raise. So that's where I'd want to get them to. They can currently do this, and then I'd plan out where I think they would get to. It's easy in tennis and in rehab when you've got someone and you control everything. When you've got a fit, healthy player, it's a little bit more challenging based on fixtures, when they fit, when you drop in training, or when they're actually training, and what you're going after. So I hope that kind of summarises it. And I hope that I've done Alex and Chris justice around describing their model, which is brilliant. I think you can see, I don't want to drop the book, but Alex's rowing book, most recent one, Strength Training for Rowing, I think it's called. There's a really nice chapter that goes through explaining it, probably in a lot more depth and detail than I have, but it's really neat, and I think it allows me to just pull all my thought, or anchor everything that I'm doing, my decisions, to a framework that doesn't necessarily mean it's right or wrong, but allows me to then reflect and go back to it as a little reflection piece for myself.
So that goes into detail on this adaptation-led approach.
Yeah.
That chapter. Okay, interesting. When you say it is controversial about a leg press, I'm not sure it is that it was pretty controversial when people started mentioning it maybe a couple of years ago, like a bit of a shock that you're using a leg press or a leg extension. But I think now more people are doing it and more open about like fixed resistance machines. And yeah, I think more people are going down this approach. We've got an article, Stephen Breisner wrote an article on this adaptation-led approach. I don't know if he was EIS at some point as well, not quite sure. But yeah, I think it's becoming more popular.
Yeah, definitely. I think it has its place, like doing your like functional move. Let's say functional movements, really generally like your squat patterns, your hinging patterns, your lunging. I think they've like are really useful if an athlete is really competent at them. And I've had a lot of conversations with some of my colleagues around like if an athlete's really competent, and again with Olympic lifts, like they're really competent at these exercises, and we're confident that they're going to be able to give very high level of intent within them, then they may be a really appropriate methodology. Um, I think again, the debate I always go back with some of my colleagues is if you're really clear around the movement that you want to change or what needs to change in the performance environment, and you work back from that, I find it really hard that you of getting to a back squat in most situations. And that's not saying I don't back squat players, because I do back squat players, but I back squat them for a different reason. I might back squat them to warm up for like a really heavy quarter squat, as an example. I had a girl the other day actually doing 180 for, I want to say it was 8 reps, a quarter squat, but she did full range back squats to warm up to get to that. But again, like it just comes from that principle of exercise selection for me around understanding the constraints of like you do an exercise that has a load of different moving parts, there's going to be constraints in the area, and it probably gives you less confidence around going after specific tissue if that's the way that you're looking to go down or the route you're looking to go down. But I think those sort of movements are really useful in those like early development phase. But as like I'm sure people are doing in like working in elite sport, like when you have a limited time frame to work with the athletes, you don't want to be teaching them movements. And this probably goes against this idea of us being an S&C coach, and actually we're probably more like instructors. And like if we're doing like a if we're doing a session in the gym with a player and it's a high force session, we want to create a high force adaptation or a change, then you probably want to put them in an exercise that they're able to express high amounts of force with less coaching. And it's that the more technical elements you remove from exercises, the more confident I think you can be in creating the change that you want. And then that ties back into that question at the top of my philosophy around have I made a physical change that's affected performance.
You mentioned early doors about the foot and ankle, and you've mentioned obviously gone into the soleus and the calf. Is there anything you do specifically around the foot, just generally because of how important it is for lots of things, but particularly this deceleration and change direction?
I think first and foremost is obviously we're kind of learning this a little bit more recently now at Man City, that the range of motion is obviously really important, and having good range of motion in both ankles is, or not having a huge difference is potentially important in terms of loading and where the load goes through the foot. Um, and then specifically, I wouldn't do load of things mobility wise. Like I'll probably lean towards that. Either I'm going after like high force, so I'm going to train to increase the structure around the tissue. And again, I'll pull it back to that framework. I'm looking to change the like physiological cross-sectional area, let's say around gastroc soleus, or I'm going to probably look to change the local state, and that'll be where I use my like reactive hops. And I'm doing a lot of stuff with some of the athletes at the moment around changing the surface type. So keeping or having variation in the surface allows, or hopefully is pushing the athlete to still maintain and co-activate um, at the foot and ankle every time they hop, but it's on a different surface, so they almost got to pre-activate before they hit the ground. But they've still got to have short ground contact times. They've still got to project themselves vertically in the air. So I do like a load of volume of that. I've also done previously and have like still program now like hops for time. And we did a lot of this in tennis because the demand on the foot and ankle in tennis is really high. We would do a lot of like single leg hopping, like lateral hopping, for 20, 30 seconds and accumulate time and volume over a period of time. Skipping, I think, is really good and useful for getting that elastic component, or training that elastic component of the foot and ankle. But again, I try not to deviate too much into the grey, and I try and stay as close to the corners, let's say, of the triangle around, try and change the structure around the calf or foot ankle complex, and changing the local coordinative state around the foot and ankle. And that's probably like based on the role I'm at the moment, where the majority of what I do is gym based. They're the two things or the two areas that I'll probably look to try and affect.
So one of the last things this has been unbelievable, by the way. Thank you so much for this. One of the last things I'll ask you is, what can football learn from tennis? Given your transition from tennis to football, what have you thought? And maybe there's loads of stuff, maybe there's nothing, but we could do that better, because like generally in tennis that's done really well.
Yeah, I think this definitely works both ways. I
Of
think
course.
the volume of training that players did in tennis was significantly more than what they do in football, and I think that comes down to the demands of the game, and like typically, like, both sports are really different. You've got team sport and individual sport, but within tennis, like, there's so many variables that you just can't control, and there's a lot of uncontrollables, like match length, who you're playing, when you're playing, where you're playing. Like, there's all these things that, like, you can't control, and you get to a point where, rightly or wrongly, like, tennis players would train for, they, like, a typical day might be, you come in, you do an hour warm up after getting treatment with the physio, 2 hours of tennis on court, lunch, hour and a half gym, recovery. Football's a bit different, and that's probably a cultural thing of why it's different. But also, like, again, as I said, the demands of the game are very different. In football, there's a lot more, like, volume of running within a week, potentially depending on what you're doing in tennis and how far you go in tournament, what tournament is, etc. But you're typically accumulating a lot more higher speed running because of the dimensions of the pitch compared to the court. So courts, obviously, you're constrained around a really small area, so you don't really get up to higher speeds. Whereas in football, the mechanical demands, especially around the hip, the hamstring, are a lot more. So in terms of, like, the biggest learnings, I think football players would be really surprised at what they're actually physically capable of delivering. And to be fair, like, we've got some really, really strong footballers. There's some footballers who, on some of our isometric tests, are putting north of 4.5 times body weight for a single leg, which is really, really impressive. Whereas in tennis, because again, of the nature and the demand of the sport, probably don't need to be as strong. The change of directions and accelerations may be more in nature, but they're probably not as intense because of the speeds that you're going to be running at. And you still run fast in tennis. Like, players will get up to decent speeds, but not as frequently as they would in football. But yeah, in terms of, like, again, and I think some of the biggest differences are just in around, like, the interactions with the people and their different experiences. I find that fascinating. Like regardless of what sport they're in, they've come from very different, like sports, and they all have different experiences of where they get to. And I find it fascinating, like, interacting with players, like some of the players in tennis who have gone on to do unbelievable things, people in football who have gone on to do unbelievable things, and, like, the thing that pulls them together is sport. And yeah, I think that's, like, one of, like, without coming too soppy, that's probably, like, one of the big drivers of why I do what I do. Like, I love helping people and, like, seeing people do really well in sport, and that's probably why I spend a lot of time in the rehab setting as well. Like, seeing people and helping them get better, and seeing, like the joy on someone's face when they run out to play for the first time in however many months they've been out sideline injured. Like, that's really rewarding. I haven't really answered your question. I've just gone around in a circle.
That's fine. That's interesting. Nonetheless, it's interesting. But the last thing I will ask you, definitely, is for you in this space, whether it be testing or training, again, pairing these two to get these things together, deceleration, change direction, what developments do you want to make with the athletes that you work with, whether, like I say, testing or the training side?
Definitely, I want to try and get the process of capturing and then interpreting the change of direction specifically information a lot more slicker, because that will allow me a lot more headroom to kind of make sense of it all instead of trying to figure out pulling all the numbers from everywhere. So is that, I think, like, again, I'm really, really lucky in the positions that I've been in, the place I've been able to work, to have the resources that I have available to do like a really comprehensive profiling. I think learning from people in other sports is definitely something that I want to do more of within next year. Because I spent like enough time. Well, I say I've spent 2 years in football, a year and a half in football, 4 years in tennis. Like, I'd like to explore, see what other people are doing in their change of direction, how they profile for it, and how they view it. There's some stuff, a little bit of work going on at the moment at Man City where we're using the Sportlight equipment, and I don't know enough about it, so I don't want to comment too much on it. But I think that potentially is really exciting, and it's a really nice way of being able to quantify and bandwidth specific players, or capacities and bandwidths of decel accelerations. So yeah, I think that's the bit that's really exciting. And again, I'll always pull it back to like making it like yeah, we've spoken a lot about change of direction, decel, and the movement that I talk about, but it's really important of how we link that back to the demands of the sport, what it takes to win, and is it important for that player? Like, because we have, it's like, don't want to jump away again, but like with one of our criteria for return to run, we have specific targets on our like isometric strength testing, and it's relative to the body weight of the individual, but it's based on the research from Dawn and Pandy, which everyone hopefully reads now and has read, at different speeds. And we have an athlete who hasn't got injured at all, but the demands of their position and what the demands of their game are is very, very different to someone who's running a lot of and running really fast, and therefore actually having a real understanding of their demands will then allow you to be a little bit or shift the bandwidths on your benchmarks. And I think that's really important as well, because it's really clear to go, right, everyone needs to get like our benchmark for an RSI is this number. Like, not everyone's going to be able to do that, and most of the time that's just how they are choosing to produce force or produce elastic energy. So I think being able to be really N=1, and that's probably the most important thing I've taken from tennis to football, is that approach of every athlete is different, will move differently, and will have a different anatomy and physical makeup, and therefore you've got to treat them as N=1, and how you train like each player for each different thing they need to be able to do has to be related back to, will it make them better at their sport, and if I'm doing something to create a physical change, does it impact performance? And that's probably the next bit, that on top of the deceleration stuff, I'm interested in being really clear that, okay, if I'm doing this, am I affecting performance? And I like to think I'm doing it well at the moment, and we are as a group for sure. But it's always that, can we be better? What else do we need to know? Like, how? And again, I always use the confidence. I've used it throughout this chat with you, of like scale of confidence. Like, how can we be more confident that what we're doing is impacting performance?
So good. Thank you for that. I'm going to let you go because it's nearly 10:15, and I'm sure you're in early in the morning. Oh, you've got to travel. You've got some travelling to do. But if anyone wants to get in touch with you, follow you on social media, where's the best place?
Probably, I can't say Twitter now because it's not Twitter, is it? It's X.
It is.
It's X.
It makes me sick in my mouth a little bit.
I think my handle is, and I don't really post anything, but I like occasionally, and I don't think you can even see what people like anymore, but I occasionally retweet the interesting, well, what I think is interesting to me, bits of research, and my handle is just C Faulkner 1993.
Nice.
So yeah, that's probably where I am.
Beautiful. I'm going to let you go. Thank you so much. Really appreciate it. Keep in touch, and look forward to seeing what develops on your side. Yeah.
Cheers, Rob. Really appreciate it.
My pleasure. Thanks, mate. Cheers, buddy.